What is type 1 diabetes? According to Harvard Health Publishing, type 1 diabetes is a disease in which the body does not make enough insulin to control blood sugar levels. I'm a software engineer, not a biologist. So what does this definition really mean? This video is my attempt to figure it out by comparing the body of a normal person to the body of a type 1 diabetic like me. Let's start with Normie, the normal person. Normie's blood sugar is currently 100 milligrams per deciliter. If we do the measurement conversion, that's the same as 1 gram per liter. In other words, for every liter of blood within the body, there's a gram of glucose floating around. Now, let's give Normie a tablet with 10 grams of pure glucose and see what happens. Yum. The glucose goes in through the mouth, down the esophagus, through the stomach, and into the small intestine. In the small intestine, glucose crosses through the intestinal wall into nearby blood vessels. Those vessels drain into the portal vein, which carries glucose straight into the liver. The liver decides how much glucose to store and how much to let through. From there, glucose enters the wider bloodstream, and Normie's blood sugar begins to rise. This is where the pancreas steps in. The pancreas has a rich supply of blood vessels and begins to detect the extra glucose in the blood. Inside the pancreas are special cells called beta cells. The pancreatic beta cells are the real stars of this story. Beta cells are like glucose sensors and insulin factories. When blood sugar rises, beta cells detect the rise and release insulin straight into the bloodstream. Insulin travels everywhere, telling muscle, fat, and liver cells to pull in glucose. These cells use it right away for energy or store for later. As these cells absorb glucose, blood sugar drifts back down to 100 milligrams per deciliter. Now, let's switch to Timmy, the type 1 diabetic. Let's give Timmy a tablet with 10 grams of pure glucose and see what happens. The first steps are the same. The glucose goes in through the mouth, down the esophagus, through the stomach, and into the small intestine. In the small intestine, glucose crosses through the intestinal wall into nearby blood vessels. Those vessels drain into the portal vein, which carries glucose straight into the liver. The liver decides how much glucose to store and how much to let through. From there, glucose enters the wider bloodstream, and Timmy's blood sugar starts to rise. Here's where things change, though. In type 1 diabetes, the immune system has destroyed the pancreatic beta cells. And since beta cells are the main source of insulin, Timmy's body can't release insulin from the pancreas. Without insulin, the signal to bring glucose into cells never gets delivered. The glucose stays in the blood, building up to higher and higher levels, instead of being used by muscle, fat, and liver cells for energy or storage. This sustained high blood sugar level leads to many symptoms such as thirst, frequent urination, fatigue, blurred vision, and can even be life-threatening. In summary, Normie's pancreatic beta cells release insulin to bring blood sugar down. And Timmy, the pancreatic beta cells are gone, and without insulin, the body has no control of blood sugar.